Hello everyone, welcome back to DhiNexus. I'm Chandhni Mariam Chako. So today we will deal with the topic, the reactions of acids and further reactions of acids and bases. And also we will be discussing what makes a substance acid and what makes a substance bases anode. So at DhiNexus, we make the learning simple, engaging, and clear. So stay tuned till the end of the session. So let's move on to today's topic. So have you ever seen that at certain times, some of our metal-based materials, they will be having a outer coating will be formed. Have you seen that? Okay, so what is the reason behind that coating? Have you ever thought about that? And how can we remove this coating? Have you ever thought about that? So the metals usually they are very reactive. Hope you know that. Okay, so always they will be trying. So they will be reacting with the components in the atmosphere, especially the oxygen anode, and they will be forming the oxide of that particular metal. Okay, so mainly our metals that we use in our home, like the copper anode, they will be reacting with the oxygen forming a metal oxide. Okay, so we know that a metal is very reactive and the metal will be usually forming oxide of that. Okay, so let's take an example of the metal copper. And what happens when the copper is combining with oxygen? It forming the copper oxide. Okay, so any metal reacting with a oxygen compound will be forming corresponding metal oxide. Okay, so this metal oxide is what is the reason behind the formation of the coating in our vessels. Okay, so what we can do, how we can remove this? Is there a solution? Yes, there is a solution. That is where our acids are entering. So here we will take an example that a copper oxide can be treated with a acid. Okay, for example, we'll take HCl. What will be forming? We will get a compound which is known as CuCl2, that is copper chloride plus water. Okay, what is this copper chloride? Copper chloride is a kind of a salt and the other byproduct is water. Right. So in the previous reactions, we have seen that which all two compounds gives us the product salt and water? Which reaction gives us the salt and water? Yes, we have seen in the previous reactions that a acid and a base react together usually to give a salt and water. Here also we see in this reaction a similar product formation. So already we know that this component HCl is an acid. So what will be this component? What will be the nature of this compound copper oxide? Definitely it will be a base because only a acid and a base will be giving salt and water. So what we can come to a conclusion from this? We can come to a conclusion that all metal oxides are bases. Okay, since we are treating that with the acid, the copper oxide is treated with the acid to give salt and water. From the base and acid reaction, we know that when an acid and a base is reacting, we get salt and water. So since here also we are getting salt and water, we can say that the compound that is combined with the acid is a base. Okay, and this copper chloride is having a color bluish green color. Okay. So that is the reaction of the metal oxide with the acid. So that is why for cleaning certain copper vessels and metal vessels, we make use of the tamarind lemon anol, because the tamarind lemon anol is containing acid inside it. These are acidic substances. Okay. This lemon anol is containing the citric acid. So that's why we usually use a lemon or a tamarind to clean the metal vessels to remove the coating that is formed in the outer covering of it. So the coating over the metal vessel, metal oxide, what they do, they react with the acid and gets dissolved, forming salt and water. So since they are forming salt, that copper oxide is being converted into salt. Copper oxide is converted into copper chloride, which is actually being soluble in water. Okay, so that is how we are removing that coating. Okay, so this is the general equation we can say about this. That is, a metal oxide and acid will be reacting together to give salt and water. Okay, so this is a similar to reaction of a base. So we can arrive into a conclusion that metal oxides are basic in nature. Okay, metal oxides are basic in nature. Hope this topic is clear to you. The color of the solution becomes bluish green and the copper oxides dissolves. The bluish green color of the solution is due to the formation of copper chloride in the reaction. Okay, is that crystal clear? Okay. So now let's see what will happen if a non-metallic oxide is reacting with a base. So we took metallic oxide treated with the acid. So let's see what will happen when a non-metallic oxide is treated with a base. So what we will take? We will take our common base, that is calcium hydroxide. Okay. That can be treated with a non-metallic oxide. So carbon is a non-metal and the oxide of that is a carbon dioxide. What is the product forming? We will get calcium carbonate plus water. What is this calcium carbonate? Again, this is a salt. And H2O is again forming water. Again, the equation is giving us the product same as that of the metal oxides reacting with a acid, right? So here we definitely know that the calcium hydroxide is a base. So what will be this carbon dioxide? What will be the nature of this carbon dioxide? Carbon dioxide should definitely be acidic, right? Then only an acid and a base reaction gives salt and water. So what we can arrive into the conclusion? Non-metallic oxides are acidic in nature. We have seen that metallic oxides are basic in nature. Here we can see that non-metallic oxides are acidic in nature. Okay, so this way you can remember, there is a shortcut for that. You can remember MOB for that, where MOB means metallic oxides are basic. NOA, non-metallic oxides are acidic. With this shortcut, you can remember MOB and NOA. Okay, this is the easiest way to remember which oxide is treated with which substance giving the reaction. Okay, so hope this video is helpful to you. If it is, if you find it helpful, please like, share it with your friends, and also don't forget to subscribe DhiNexus. Okay. We know that there are a lot of materials are there, right? Like the H2SO4, HNO3, HCl. So we commonly call that as acids, right? So why are these materials known as acids? What makes them acids? What's so special about this substances that is being named as acids? So that is where we need to understand that what do what do all acids have in common? Okay. So all these acids are having certain things in common. For that, what we need is that we need to put them in water. Okay. So whenever an acid is put into water, we see that they dissociate. They dissociate into ions. And that ions will be producing H plus ions, especially. So the substances that release H plus ions, they are termed as acids. Okay, so all these acids like H2SO4, HNO3, HCl, when they will be putting into water, they will be releasing H plus ions. Okay, so that is where this ions, for example, we will take H2SO4, okay? So we put that in water. What happens is that we get 2H plus and SO4, 2 minus ions. Okay, likewise, we will put HCl also. The HCl, the H plus and Cl minus ions will be evolving. Okay, so that is where all the acids will be having one thing in common, that is the releasing of this H plus ions. Okay, so that makes them acid. So all acids produce hydrogen ion, or they are also known as hydronium ions, that is H3O plus releasing also, they will also be uh, termed as acids. Okay, so either this H plus or hydronium ion releasing substances are known as acids. But in presence of what? Only in presence of water, the acids will be dissociating into ions. Okay, dissociating means they will be splitting into ions. Okay, so here you can see the reaction. HCl is being put into water. We get the hydronium ion, that is H3O plus and Cl minus. Okay, so H plus and H3O plus is responsible for the electrical conductivity of acidic solution. So if there is air, ions is releasing means they will be conducting electricity. Okay. Any material that is dissociating into ions will be conducting in nature. So for acidic substances, that is the release of the H plus ions are a reason for the conduction of the electricity. Okay. So some substances do not form H plus ions in aqueous solution. Even though the element hydrogen is present in the compound, they are not acids. Okay, so for example, the glucose, alcohol, and all, they contain the H is present in that, but that won't be dissociating into ions. That won't be dissociating into H plus ions when this glucose, alcohol, and all is put into the water or aqueous solution. So they are not considered as acids. Only those components that can produce hydrogen ion, that is H plus ions or hydronium ions, like H3O plus is considered as acids. Clear? Okay, so a glowing bulb. So if we are actually taking a acid into water, like HCl, and water is there. So this HCl will be splitting into H plus and Cl minus. Okay. So what happens is that if we are connecting two electrodes, again connecting that with the cell, okay, what happens is that since this HCl is dissociating into ions, this solution will be conducting the electricity. Okay, as a result of that, if we are connecting a bulb, we can see that this bulb will be glowing. So if a bulb is glowing through a solution, we can see that that solution is conducting the electricity. So for the conduction of electricity through the acid solution is because of the presence of H plus ions. Okay, so the acid contain H plus ions as cation. Okay, so when a compound is dissociating into its ions like H plus and Cl minus, the ion with a positive charge is known as cation and an ion with a negative charge is known as anion. Okay, so that is where H plus ion is cation and anions such as Cl minus in HCl, NO3 minus in HNO3, SO2 minus in H2SO4, CH3COO minus in CH3COH. Since the cation present in acid is H plus, this suggests that acids produce hydrogen ions, that is H plus ions in the solution. These are responsible for the acidic properties of that particular acid. Okay, so I hope now you understand what make a substance acidic. Clear? Okay. Then what about bases? What make a substance bases? So let's take some examples of certain bases and all. Okay. So let's take a base NaOH. When being put into water, what will happen? This will be dissociating into Na plus and OH minus. Similarly, we will take example of calcium hydroxide. What happens? This will be dissociating into Ca2 plus and 2OH minus. So what is common for these two bases? What is common? You can see that OH minus ions are common. OH minus ions are common. So when this certain substances put into the water, they are dissociating into the ions and they are releasing OH minus ions that are known as bases. Okay. So all bases produce hydroxide ion, that is OH minus, or they are also known as hydroxide ion in the presence of water. Taking the example of NaOH, it is dissociating into OH minus and Na plus. And calcium hydroxide is dissociating into OH minus and Ca2 plus. So hydroxide ion is responsible for electrical conductivity in basic solution. So in acidic solution, H plus is responsible for electrical conductivity. And for basic solution, it is OH minus ions is responsible for the electrical conductivity. Okay, so hope it is clear to you. So what happens to an acid or a base in water solution? If a question is asking like this, what you will be writing? You should write that acids gives H3O plus or H plus ion in water. Bases generate hydroxide ions in water. The strength of acids and bases depend on its number of H plus ions and OH minus ions present. Acids give rise to more H plus ions are said to be strong acids, and acids that give less H plus ions are said to be weak acids. Okay, so there is also another classifications like strong acids and strong bases and weak acids and weak bases. Okay, so strong acids means while they are dissociating, they will be producing more H plus ions in water. Strong bases, they will be producing more OH minus ions in water. So what will be weak acids and weak bases? So definitely the opposite. The weak acids will be producing less H plus ions in water, and weak bases will be producing less OH minus ions in water. Okay, so weak acid produce less H plus ions. Weak base produce less OH minus ions in water. So all this happens in presence of water. That needs to be remembered carefully. Okay, so hope all these topics are very much clear to you. Okay, so today we discussed about the reactions of acids and bases with the acids with the metal oxide and bases with non-metallic oxides and their products we discussed. Then also we discussed what is the thing that the acids are having in common and what do all the bases having in common. What is the reason behind the electrical conductivity of acids and bases? And what are strong acids, strong bases? What makes a substance weak acid or a weak base? Hope this topic is very much clear to everyone. With more interesting topic, DhiNexus will be again coming. So stay tuned until we come with the next topic. Bye everyone. Thank you.